So completing the square, it's one of those factoring things that we really don't make that much use out of. It's like, why are we spending time with it then? Well, we do see it a lot when it comes to graphing our parabolas. Completing the square puts in something called vertex form, which makes it very easy for us to graph. So don't recommend just factoring, saying, hey, let's do complete the square. But because of our graphing that goes along with this in Algebra 1 and Algebra 2 as well, completing the square is a technique we want to be aware of. And let's show you how it works. So what we're going to do is make it into a problem where we can use our perfect square. And the idea is we want to get it into something like this. Because when we're graphing, it's going to allow us to find the vertex. And in this particular problem, if we were graphing this particular equation, our vertex would be at the ordered pair 3, 8. We take the opposite of who's in the parentheses, and then we use who's outside the parentheses. And then we can get into our whole 1a, 3a, 5a, or whatever a technique that we want to use for finding a few of our other points. So, like finding zeros. Sorry, it slipped me there. So that's the end result. So let's get into it. If we have something like x squared plus 6x plus 5. All right, so the idea here is we can't simply do, we can factor it, all right, but we want it in a form where it's a perfect square, as in it's a repeat. So as much as like, well, yeah, let's just do x plus 5, x plus 1. Yeah, that's gonna work, but it's not going to allow me to simply graph it and find the vertex. So here's how this ends up working. What we need to end up doing is clearing some space. Okay? And to do that, because it's an equation, all right? Even though you're like, well, there's no equal sign. Yeah, technically we are set equal to 0 because it's an equation we're going to be graphing here. What we're going to end up doing is we're going to get rid of that whole number. So we just have this blank spot that's there. And then equals -5. Because 0 minus 5 is -5. So formally what they'll tell you to do is they'll tell you b over 2 and then square it. All right, so remember your x squared is your a term, your x is your b term, and then your plain old number is your c term. So what we have to end up doing here is taking half of 6. Well, half of 6 is 3, and then we square it. 3 squared is 9. So we get an x squared plus 6x plus 9. Now, the thing though is, because we added 9 to the left-hand side of the equation, to stay fair, we have to also add it to the right-hand side of the equation as well. And this is that whole balancing thing that's here. Now it allows us to factor. And this is going to be a perfect square trinomial. And it's not one of those where you're like, well, wait a second. Last video you talked about it needed to be a subtraction sign. We did. But that's when it's a binomial, 2 terms. We're dealing with a trinomial here. So when we factor this here, I notice it's a perfect square, which is my 9. And this is going to happen every single time. Every single time. It's always going to be this. And let's check it out. What is 3 times 3? 9. What is 3 plus 3? 6. And that's what this thing over here takes care of. It forces it always to be a perfect square. It's always going to end up being that. So on the other side, we got -5 plus 9, which is simply our 4. And now what we're ready to do is clean it on up. So because it's repeat multiplication, we write it as an exponent. And then we're going to bring that 4 over, so we're also going to have to subtract it over. And there it is. There it is. This will allow me to graph my parabola. So it is factored. It is in a factored form. What we typically end up doing then is this would get us our vertex. So it's the ordered pair -3, -4. And again, we're going to take the opposite of who's inside the parentheses. And then we're going to use who's to the outside. So if we kind of sketch it, -3, -4, somewhere right around there. If you go back to the original problem, remember this factors as, whoops, that's not it. Hold on. There it is, way up there. X squared plus 6x plus that 5. All right. So yeah, let's get that written down there. X squared plus 6x plus the 5. If I factor this, I'm going to get x plus 5, and we're going to get x plus 1. Two numbers that multiply to 5, but add to 6. And what this ends up doing for me is it ends up getting what we call our zeros. And remember, your zeros is where it crosses the x-axis at. So we talked about our vertexes at -3, -4. And we also know that if we solve this, we're going to get x equals -5, and we're going to get -1. And the idea behind that is remember when we solved, we said equal to 0. So what do you add on to 5 to get to 0? Well, -5. So now what we've got are 2 more points that are here. And now we can get a really nice sketch of our parabola that we're looking at. Huh? Yeah. All right. So again, that's where it's all leading to. Again, we'll focus more on the technique here, but as always, we do want to kind of see where things are going to. And we can put anything into a complete the square. Anything at all. So don't feel like, well, wait a second, I need this. No. We can always end up doing that. And again, the whole goal is to get it into vertex form. So normally you're not going to be like, hey, I need a factor. I guess I'll do complete the square. Yeah, no. But it is a factoring technique here. So let's try x squared plus 8x minus, let's say, 4. All right? So here, remember, we've got to get that whole number, and that c, we got to get rid of it. So it's x squared plus 8x. We're going to have to add that 4 to the other side, because remember, it is an equation that's there. So when we add that 4 over, there's nothing there anymore. I'll put it down there. All right? And 0 plus 4 gives us a 4. So remember, we take half the b term, and then we square it. So half of 8, 4, and then square it, we get 16. Remember, because we're adding a 16 onto one side of the equation, we've got to do it to the other side as well. So there we are. Now we're ready to go. X plus 4, x plus 4. And again, 16 that's there. Remember, it's going to be a perfect square. It's going to repeat every single time. So half of 8 is 4. You can think about it from that standpoint. The square root of 16 is 4. All right. But yeah. And now we're ready to go. So it's x plus 4 squared. And we got to bring that 20 back over. And then there's your minus 20. And we're set. Again, complete the square gets us into vertex form. That's when we're going to use it. We're not really going to use it in many other situations. There is a solving situation where you might use it there, but typically students would go with another technique that we're looking at. All right, so let's throw another one at you here, and let's see if you can get it from start to finish. X squared plus 12x minus 5. And again, we can set it equal to 0 right away for you. All right, pause that video, see if you can do it. All right, did you add that 5 over? All right, so did you clear some space? X squared plus 12x plus the, all right, sorry for the sound effect there, but yeah, that's the idea. There's nothing there. Yeah. All right, adding the 5 over, so we get our 5. Did you take half of 12? Did you square it? So half of 12 is 6, and you square it, you get 36. So we are adding a 36 onto both sides. And now we're ready to jump right to it. I mean, you don't have to put down the x plus 6, the x plus 6, because you know it's going to repeat. And again, we know it because we are completing the square. I'm going to get an x plus 6 squared. 5 plus 36, well, that gives me 41, but I got to bring it back on over. So we're going to subtract that 41 over. And there we go. We'll be ready to take it from there. So there you go. So again, something we really don't go to, they typically tell you when to use it. They'll say, hey, why don't you solve this by, because really no one uses it unless we are graphing. And even if you're graphing, you've got other techniques. You don't have to use complete the square. So again, it's a good one that's out there to be aware of. It has its benefits, but it's not one of those, all right, it's a life preserver. I need that in an emergency situation when I'm out on the boat. We'll see you later.